Good afternoon, students. This is Mr. Langham. I'm going to show you how to do the Newton's second law concept builder today. It's a pretty easy one, but I know sometimes it's helpful to see someone else do it first before you can do it on your own. So I'm going to work through each level, go through a couple questions on each level together. So remember, Newton's second law is all about the relationship between force, mass, and acceleration, F equals ma. So we're going to go ahead and start with the apprentice level. So all you're doing with these problems is you are entering either the acceleration, mass, or force based on a change to another variable in the formula. So this first one says an object has an acceleration of 18 meters per second squared. If the mass of this object were tripled without a change to the net force, then the new acceleration would be what? So first thing we need to know is the relationship between mass and acceleration with Newton's second law. And that relationship is inversely proportional. That means one goes up, the other goes down. So if the mass goes up, in this case, we know the acceleration is going to go down. So it's going to be less than 18. Now the actual mathematical relationship here, in this case, if the mass is tripled, then that means the acceleration is going to be cut down to a third of what it was originally. You just take the 3 from the numerator, put it in the denominator, comes 1/3. So if that's going to be cut by a third, 1/3 of 18 is going to be 6. Check answer. Data away. Hooray. So next one here. Object has an acceleration of 18 meters per second squared. If the net force acting on the object is doubled, then the new acceleration is what? So in this case, we need to know that net force is directly proportional to acceleration. That means that the force goes up, acceleration is going to go up. And it's doubled. So if the net force is doubled, that means the acceleration is also going to be doubled because that's a direct relationship. So that means this 18 meters per second squared is also going to be doubled. That's going to be 36. So pretty simple. And the nice thing about this one is all levels are pretty much the same. So let's go back to the main menu. Go to the master level. So we have a scenario here. It says an object has an acceleration of 12 meters per second squared. If the net force acting on the object is halved, means 1/2 of the original force, then what's its new acceleration? Well, in this case, the force and the acceleration are directly proportional. That means if force goes down, acceleration is going to go down. So here we have a case where the force is being cut in half. That means whatever happens to the force is also going to happen to the acceleration. It's direct. And if the net force is cut in half, the acceleration is also going to be cut in half. So it's going to go from 12 to 6. Check answer. We're good. This one says an object has an acceleration of 18 meters per second squared. If the mass of this object is reduced to 1/3 of the original value, then what's going to happen to the acceleration? Well, the mass is going down. That means the acceleration is going to go up. It's going to speed up at a higher rate. Once again, we're just going to flip the fraction here. So if the mass goes down by 1/3, we'll take that reciprocal. We'll flip the 1/3, and now we have 3. That means the acceleration is going to go up by 3 times. So 3 times 18 is going to be 54. And we're good again. So this is all you're doing for each level. I mean, they supposedly get a little bit harder, but I mean, let's do one for the wizard level here. It says an object has an acceleration of 18 meters per second squared. If the net force acting on the object is tripled, what's the new acceleration? Well, that's not any harder than the ones we already did. So net force is going to be tripled. That means accelerations also can be tripled. And look at that. It's the same flipping answer. 54. Okay, so look at that's not that hard, right? If you have any questions, though, just let me know. I think this one will be a pretty easy one. All right, well, see you soon. Good energy.